Okay, good afternoon, class. So today we're looking at Euclidean geometry. We're looking at example 12. And example 12 is on page 269. And these are the examples for exercise 6 on page 272. Okay. Here we are told that ABCD is a cyclic quadrilateral. So if ABCD is a cyclic quadrilateral, all cyclic properties are evident there. Okay? What are the examples? That those two angles adds up to 180. They are supplementary. Okay? We also know that angles in the same segment are evident here. And so on and so on. Okay? There's no x here. P1 is also equal to angle D1 and 2. And what's the reason there? The exterior angle of cyclic quad equals the interior opposite. So by them telling us that's a cyclic quad, all those rules are evident there. Then we are told that chord BC is equal to DC. As you can see, it's marked here. So BC is equal to DC. If that's the case, we know that A1 and A2 is going to be equal in size. Why? Equal all chords are equal angles on the same side. Okay? Then we are also told that ECF is a tangent to the circle at C. So if this is a tangent, then C1 is equal to angle A1. Why? Tan chord theorem. And so is C4 as well. Okay? Chord AB is produced to meet tangent at E, which is this point here. AC and BD are drawn. Prove that. Let's prove that BD is parallel to EF, which is this line. So if lines are parallel, we know that alternate angles are equal, corresponding angles are equal, and co-interior angles are supplementary. So when we prove these lines are parallel, we prove now one of those cases where alternate angles are equal, corresponding angles are equal, or co-interior are supplementary. Okay? So let's see. Okay, so this is fairly simple. I can, if A1 is X, okay, let's see if we can get the F out of here, or Z. I think we can get the Z out of it. Not so? So C1 is actually equal to, angle C1 is equal to angle A1, not so? And A1 is also equal to A2, and A2 is equal to B2. There we can see the alternate angles are equal. Can you all see that, people? So let's lay that out nicely now. So we start off by saying, let C1 equals X. By doing that, we know that angle A1 is equal to XY, the tan chord theorem. Okay. Then we see that A2 is also equal to XY, because it's equal chords, subtends equal angles on the same side. Okay, so that means to say there's also an X there. Then A2 is equal to B2, which is X, angle in same segment, and it's coming from arc CD. Okay, so now we can say, you see those two angles are equal. So now we state the obvious. We say since B2 is equal to C1, which is equal to X, therefore BD is parallel to EC or EF. Why? Because of alternate angles are equal. Can you see that, people? The alternate angles are equal. There's some good couple of marks that can be bagged in. Okay? And like 4 marks. I'm seeing already 4 or 5 marks. 1, 2. Yeah, 4 marks. Okay. Or I could, there was actually an easier way. I could have said that C1 is equal to D2. Why? Tanko theorem. Not so. D2 is equal to B2. Why? Angles opposite equal sides. Can you see that? What can I say here? And I could have, okay, it would have probably been 3 marks for the sum. And not 4. What was that? That would have been an easier route, the quicker route, to prove that those lines are parallel. But you guys understand? Right. I need to take this off as to have the diagram in focus. I'm going to put my x's again, which angles I marked already to be x. Don't think I went with that one, no? Alright, but at this point I know that these lines are parallel. Okay. So let's look at B. B. So now they want you to prove that CD, so let's go to CD. CD, this line here, but CD is the same as CB. Can you see that? So I could use one of the two there in this place. BE, which is this line here. CD, which is again that line there. And AB, AD, this line here. Okay. So which two triangles do you think we're going to work in? Sorry? B, E, C. Okay? And A, D, C. Why do you think you're going to work in those two triangles? The most lengths that we picked up all the lengths that they're referring to, not so? So I'm going to start off by saying in triangle. I'm going to say in triangle BEC and triangle ADC. Right, so what can we say of those two triangles? I had to leave it highlighted. It would have been easier. What can I say? We're going to prove similarity and the two triangles are similar, not so. So what can we say? We say that angle C1 is equal to angle A2y, which is xy, proven. So it was proven above already. Now if you didn't at this point gone with that route that I showed, we had gone the shorter route, then you would have said now that A2 is also equal to xy. Firstly, A1 is equal to x, tan chord theorem. A2 is equal to x, angles, equal chords, opposite equal angles. Equal angles, opposite equal chords, sorry. Okay, you guys understand? But since I went that route and I marked it x already, so I've marked it so I can use proven. Okay, then we need another angle. B1. Angle B1 is equal to angle, I said it earlier on, D1 and 2, so it's ADC. Why? It's the exterior angle of cyclic quadrant.